Hello, and welcome to this presentation about the potential of the Lava-Pinta Trail as a geological trail. You may know that the Lava-Pinta Trail is a hiking trail in Jericho, or the West MacDonnell National Park in Central Australia. The trail is about 220 kilometers long. It is separated in 12 sections of 9 to 29 kilometers. They permit day walks or overnight walks or multi-day walks. And the Lava-Pinta Trail is situated west of Alice Springs, starting in the east at the Alice Springs Telegraph Station and finishing at Mount Sonder in the west. It crosses the MacDonnell Ranges, the Shoeings Range, the Heavy Tree Range, and the highest point indeed is Mount Sonder with 1,379 meters. The trail is in central and western Aranda country, and the traditional owners, the Aranda people, lived there for at least 35,000 years, as evident by archaeological sites in that area. The landscape has deep spiritual significance for the traditional owners through sacred sites and songlines. European settlement only started after 1862, when John McDowell Stuart made his way through the Red Centre. Some of the historic sites can still be visited along the trail, and that includes the Alice Springs Telegraph Station. The trail winds through spectacular landscapes, and examples include Mount Sonder, Ormiston Gorge, Counts Point, or Stanley Chasm and Emu Ridge. If you want to know more about the trail, there's plenty of information available online, and there are maps and more information can be purchased at local shops and the Alice Springs Tourist Information Center. Now, geologically, the trail straddles the boundary of two very different geological regions in the south of the Northern Territory. As we zoom in to the area west of Alice Springs, you can see that in the north the rocks are basement rocks of the Aileron and Warumpi provinces. They are metamorphosed and deformed rocks that formed about 1800 to 1500 million years ago. These rocks are unconformably overlying or faulted against sedimentary rocks of the Amadeus Basin. They are much younger. They formed about 830 to 360 million years ago, so from the Neoproterozoic through to the Devonian. And you may have noticed in the Google Earth imagery that I showed before these large-scale folds and faults, and these structures, most of them have formed during the Alice Springs orogeny about 450 to 300 million years ago. Now, how do the rocks look like in the field? Basement rocks consist, for instance, of granites and gneisses, where it is very easy to point out minerals and fabrics. There are pegmatites and dolerite dikes that can be used to indicate igneous activity in the earth crust. And we have metasedimentary rocks like quartzites, mica schists, or paragneisses, and all of them can be used to point out different origins and metamorphic histories of various metamorphic rocks. But there are also many rock relationships along the trail that can be pointed out to the interested layman. For instance, we have intrusive contacts of pegmatites with different host rocks. We have deformed contacts in gneisses or mafic enclaves in felsic igneous rocks. But really what makes the Lava-Pinta Trail very suitable as a geological trail is its high diversity of geology, including sedimentary rocks of the Amadeus Basin. Here, for instance, sandstones that show sedimentary structures like ripple marks. But we also have siltstones, we have carbonate rocks, all indicate different paleo-environments. Within the carbonate rocks, there's a huge diversity of sedimentary structures and post-depositional alteration. But I think probably one of the most fascinating parts are the preserved, circa 800 million years old stromatolites. Those are these dome-shaped structures in the bottom picture, and they formed from microbial or algae mats in shallow seas. just as they are still do today. These are one of the indications of earliest life forms on Earth. However, the interest of the Lower Pinta Trail as a geological trail does not stop at the diverse lithologies. There are structures that are actually dominating in the landscape, and you can point out shear zones and show how rocks change from gneissic rock into a mylonitic rock or an ultramylonitic rock, including the subsequent development of brittle structures. There are ductile and brittle folds, like here isoclinal asymmetric folds and chevron folds in the centimeter scale, and we can show 10 to 100 meter scale anticlines and synclines easily in the landscape. There are brittle structures such as slickened sides, brittle fold plane, and sets of fractures in a fracture zone. And we have fluid flow related structures such as breccias and iron-rich concretions. But I guess one of the most spectacular concepts that you can show at the Lower Pinta Trail are the unconformities that are here, huge time breaks. For instance, the unconformity between basement gneiss and Amadeus Basin siltstones and sandstones, about 1 billion years unconformity. And that is even higher when you have basement mica schists overlain by Cainozoic conglomerates. And the diversity and structures, the diversity of rocks and structures that you can see along the trail can easily be used to point out basic geological concepts to the interested lay person. For instance, igneous activity, what is sedimentation and how does metamorphism work? What is the relationship between basement and basin rocks? And how do pegmatites intrude as silts and dikes and veins, for instance? You can show absolute and relative time relationships in rocks and units. And because of the dominance of structures in the field, it is quite easy to highlight the concept of movement in the earth crust. How do brittle folds form, ductile shear zones? What is reverse, normal, or oblique movement along a shear zone? And how does that affect the landscape? The trail, of course, would need to be accompanied by simplified geological maps. And here's just one example of the area just west of Alice Springs, with section 1 of the Lower Pinta Trail shown in yellow and section 2 shown in blue. You can point out your outcrop stops and in relation to those, the location of units and lithologies that you point out and of structures like folds and shear zones. But of course it doesn't stop at the geology, because we have a huge diversity of plant species like wild orange or river red gums or the McDonnell Ranges cycads, and also animal species like rock wallabies or the sacred kingfisher, many of which are endemic to the McDonnell Ranges bioregion. So in summary, really the Lower Pinta Trail has a huge potential to be a geological trail because it is easily accessible. There is a huge flexibility for walkers of diverse fitness levels and time available. The Lower Pinta Trail is an existing hiking trail and it is maintained, and detailed information is provided by the Northern Territory Government Parks and Wildlife. And geologically it is highly diverse and very interesting because you have the basement and the basin lithologies. You can show rock relationships and ductile and brittle structures like in the centimeters through to the landscape scale. And something I haven't pointed out yet is the diverse geomorphology and ecology interaction. Together with the high biodiversity and the cultural heritage, the Lower Pinta Trail really provides a fantastic opportunity to inform people in the field about the connections in the Central Australian landscape. So I hope you enjoyed that presentation and thank you for listening.